Sorry for the interruption. Here, after solution issues positive deviation from Rhodes law and negative deviation from Rhodes law, they have a concept called azeotropic mixture. Concept called azeotropic mixture. Okay, this is what I have explained already. Once again, I am explaining that azeotropic mixtures are the solution which boils at constant temperature and can distill unchanged in composition are called azeotropes or azeotropic mixture. In Greek meaning, boiling without change are called azeotropic mixtures. Okay. Here, what is happening? Azeotropic mixture means their particular concentration will be there of the components. In this, I am giving an example of ethyl alcohol and water. Ethyl alcohol having proportion 95.6% and water is 4.4%. Ethyl alcohol is 95.6 and water is 4.4. If I am going for a distillation of these two, what happens that ethyl alcohol and water together they will come out. Together they will come out. They distill at the same temperature. Suppose if you don't have a composition of ethyl alcohol is not 95.6, not 4.4. Not 95.6, not 4.4, then what happens? Suppose think in this way, ethyl alcohol we have 60%, water is about 40%. Then what happens? Ethyl alcohol, boiling point of ethyl alcohol is 351 Kelvin and boiling point of water is 373 Kelvin. When it is not azeotropic mixture, ethyl alcohol will come out. Ethyl alcohol will come out. And that is 95.6% and water is 4.4%. Okay. There ethyl alcohol will come out because it is not azeotropic mixture. Suppose if it is an azeotropic mixture, then what happens? Ethyl alcohol and water will not separate. They are not coming separately, they are coming together because they are azeotropic mixture. So ethyl alcohol is 95.6% plus water is 4.4, then it is called azeotropic mixture, right? So in the azeotropic mixture, we have two types of azeotropic mixture. Two types of azeotropic mixtures are there. Two types of azeotropic mixture. Two types of azeotropic mixtures are there. In that, first one is minimum boiling azeotropic mixture and another one is maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture. And second one is maximum boiling azeotropic mixture. Maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture. Second one is maximum boiling azeotropic mixture. Right? What are minimum boiling azeotropic mixture? Minimum boiling azeotropic mixtures means azeotropic mixtures where they shows large positive deviation from Rhodes law. Those solutions which shows positive deviation from Rhodes law, they can become an example for minimum boiling azeotropic mixture. And opposite to this, those solution which shows negative deviation from the Rhodes law, they are minimum boiling azeotropic mixture. So here this minimum boiling azeotropic mixtures are what? This shows minimum boiling azeotropic mixture. This shows positive deviation from Rhodes law, and maximum boiling azeotropic, this shows negative deviation from Rhodes law. Simple meaning. This is simple meaning. Ethyl alcohol and water. Ethyl alcohol and water they shows minimum they are minimum boiling azeotropic mixture. Ethyl alcohol and water are minimum boiling azeotropic mixture, and we have HCl and water. HCl and water they are maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture. These are the mixtures which shows positive deviation from Raoult's law, or somebody says large positive deviation from Raoult's law. They are minimum boiling azeotropic mixture, and those solutions which shows negative deviation from Raoult's law are maximum boiling azeotropic mixture. Means what? What we are expecting their boiling point now, compared to that they boils at the more. They are maximum boiling azeotropic mixture. Example here, minimum boiling azeotropic mixture. I have given example is this one. Minimum boiling azeotropic mixtures are ethyl alcohol and water. See, ethyl alcohol boiling point is 351 Kelvin. Boiling point of water is 373 Kelvin. When this mixture is there, they together they boils at 351.5 Kelvin. Together they are boiling at 351.5 Kelvin. Okay. And maximum, this is minimum boiling azeotropic mixture. Maximum boiling azeotropic mixture, we have an example for maximum boiling azeotropic. We have 20.2% HCl solution. 20.2% HCl solution. Here 20.2% is HCl, remaining is water. 20.2 volume by volume is HCl, remaining is water. That is 79.20 is this, 79.8 is water. Okay. The maximum boiling azeotropic mixture. See students, in syllabus they have not discussed much about the azeotropic mixtures. They are given azeotropic mixture. What is the definition of azeotropic mixture? And just they given some line, minimum boiling azeotropic mixture. Okay, which shows positive deviation from Raoult's law. Those solution which shows positive deviation from Raoult's law are minimum boiling azeotropic mixture, and the solution which shows negative deviation from the Raoult's law, solution which shows negative deviation from Raoult's law are maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture is, I have given ethyl alcohol and water, minimum boiling azeotropic mixture, and maximum boiling azeotropic mixture examples are, we have that is 20.2% of HCl. Okay. Now what I do that, for NEET level they are asking something about the azeotropic mixture. I am going to explain about that. So this much is there in your theory syllabus. Regarding azeotropic mixture, right? Okay, so in theory they are asking what are azeotropic mixture, that's it. And minimum boiling, if you have an idea about the minimum boiling azeotropic mixture and maximum boiling azeotropic mixture is also good. Minimum boiling azeotropic mixtures, these are the mixtures which shows large positive deviation from Raoult's law. They are non-ideal solution, no doubt. This shows large positive deviation from Raoult's law. What type of solution which shows large positive deviation from Raoult's law? Solutions where there is a repulsion between the components. They are not liking each other. The solution in which there is less force of attraction between the component are large positive deviation from Raoult's law, and solution which shows the solution in which there is an attraction between the component, which shows negative deviation from the Raoult's law. Okay, correlate. Maximum boiling azeotropic mixtures. Maximum boiling means they boils at higher temperature. Maximum boiling azeotropic mixtures are showing negative deviation from Raoult's law. Minimum boiling azeotropic mixture, minimum boiling azeotropic mixtures are showing positive deviation from Raoult's law. Right? We go for some graphs. Graphs are not given in NCERT and are not required, but have an idea what exactly azeotropic point represents. What happens at azeotropic point where they are distilling, right? Now I'm writing for minimum boiling azeotropic mixtures. Graph is like this. Minimum boiling azeotropic graphs, that is temperature. X-axis is temperature. This is mole fraction of water. X-axis is mole fraction of water. Y-axis is temperature. This is temperature. This is mole fraction. Right. Here, what we have is this side at this point I am taking ethanol. Ethanol composition is more. Ethanol, and this point I am taking water. Here ethanol is more. Here water is more. Mole fraction versus temperature. We know that ethanol boils at a temperature 351. Temperatures are there. Here it boils at 351 Kelvin. 351 Kelvin. And water boils at, we know that it is boiling at 373 Kelvin. Now these mixtures are mixing. Then what happens that this is the graph 351 Kelvin. 351 I'll write down. Left side I'll let me write. This is 351 Kelvin. 351 Kelvin. This is temperature graph. Okay. 351. At this point, okay. And liquid, this is for vapors. For liquid, it is coming like this. For liquid, it is like this. For this is vapor. This is for a liquid, complete liquid mixture, and above one is for vapor. This is for vapor. This is for vapor. This point is there now. This point is called azeotropic mixture. At this composition, it is forming azeotrope. It is forming azeotrope. At this point, what we have, this is azeotrope. Here, mole fraction of water is how much? 0.056, and mole fraction of ethyl alcohol. If you take mole fraction of ethyl alcohol is 0.944. 0.944. Okay. If I am taking 95 0.944 we have. So, what I wanted to explain from this graph is, at this point you see that this is for liquid. I am plotting a graph of temperature versus mole fraction. At this point temperature is 351. Temperature is 351.5 Kelvin. At that point, this starts boiling there. Okay. Another graph is together I will explain. Together I will explain the graph. Okay. Again, for liquid, the solution shows negative deviation from a Raoult's law. Minimum volume azeotropic mixture, and we have this is water. This side we have HCl, and mole fraction of HCl I am taking mole fraction of HCl versus temperature. Mole fraction of HCl versus temperature. Now for a liquid, it is like this. So for vapors, around 373 Kelvin. Water boils at 373 Kelvin. Then for this is for liquid, we have this is azeotropic point. This is for liquid, and dotted line that is for vapors, and this is at 188 Kelvin. HCl 188. S2 is 373. That boils at 188. This is 373. Liquid, and azeotropes. Azeotropes are forming. Azeotropes. This point, azeotrope, where we have mole fraction of HCl is 0.11, and remaining one is water. Okay, because it is 20.2%. This is 20.2% HCl solution. 20.2% HCl solution. And this is 95%. 95.6% ethyl alcohol. 95.6% ethyl alcohol. Example. So, what are these graphs are representing? Graphs are not important for theory. Only thing is that I wanted to show that from these graphs, what is the composition of the liquid as well as vapor. What is the composition of liquid as well as vapor at a particular temperature. You see at this point, this shows they are this is minimum boiling azeotropic mixture and they are maximum boiling azeotropic mixture. This is for maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture. Second one is maximum boiling azeotropic mixtures. What is happening? You see there. This point, whatever the points are there. At this point, the mole fraction of HCl as well as water is constant. Same. They are same. At this point, you see that H2O, HCl, mole fraction of HCl versus temperature. If you are plotting a graph, there what happens? HCl this side decreases, water this side decreases. The mole fraction of water is decreasing from left to right. Mole fraction of HCl is decreasing from right to left. But you see that at this point, at this particular temperature, both are having same composition. That is an azeotropic mixture. At that point, whatever the composition is there of this H2O and HCl is same. Its mole fraction is same. That is what I wanted to show. The mole fraction is same here, right? So both the liquids HCl and H2O here they boils at 381 Kelvin. Boils at 381.6 Kelvin. 381.6 Kelvin, and this is 351.5 Kelvin. What are this? This mixture boils at 351.5 Kelvin. This mixture boils at 381.6 Kelvin. Solutions which are minimum boiling azeotropic mixture, they boils at 351.5 Kelvin, whereas this boils at 381.6 Kelvin. See that water boiling point is 373, HCl boiling point is 188. When I'm mixing HCl and water, they boils at higher temperature, that is 381.6. That is why they are called maximum boiling azeotropic mixture. Minimum boiling azeotropic mixture, maximum boiling azeotropic mixture. They boils at minimum temperature. This mixture boils at maximum temperature. They vaporizes. They will come out. HCl and water. They will, both the liquids will come out at 381.6 Kelvin. Here ethyl alcohol and water together they will come out at 351.5 Kelvin. Okay, that is a boiling point of the solution. This is a boiling point of the solution. 381.6, 351.5. This graph, what they are representing, I have taken example of 95.5% ethyl alcohol, 20.2% of HCl. Here the mole fraction of HCl is how much? And mole fraction of ethyl alcohol, you see that. Mole fraction of ethyl alcohol is 0.944. At this point, the mole fraction of ethyl alcohol is 0.944 and H2 is 0.056. Okay. And at this point you see that HCl ratio is, at this point HCl is 0.11. Means what? Here it is 1. It is 1.0. Let us say it is coming 0.9, 0.8, 0.7. Keep on coming down. At this point you see that at this point the mole fraction of HCl is 0.11. Mole fraction of ethyl alcohol is 0.944. Remaining is water. So these are points where the ratio is same. Right? My idea is to show from this graph is this points only, not much. Graphs and all, they are not asked any question related to entire graph. Even in NEET, they are not asked related to graph. But this point represent what I wanted to show, that in minimum boiling azeotropic mixture and maximum boiling azeotropic mixture. Now we go for examples. Examples are very important, friends. You see that, because you don't create your own example for azeotropic mixture, because I said that in the beginning of azeotropic, ethyl alcohol and water, if the ethyl alcohol percentage is 95.6, water is 4.4, then only they are azeotropic mixture. Other than this, different percentages there, they are not called azeotropic mixture. That is why I am giving now some examples. Some examples I am giving now for azeotropic mixture. If you know that table means sufficient for NEET and JW level. Minimum boiling azeotropic mixture and maximum boiling azeotropic mixture. If you know those examples means sufficient. So examples for minimum boiling azeotropic mixture now. Now I'm giving examples for minimum. Examples for minimum boiling azeotropic mixture. Minimum boiling azeotropic mixture. Minimum boiling azeotropic mixture. There we have a list. Table is like this. Components. That is A and B components. Composition. Next one is composition. Next one is composition. Next, boiling points. These raters are collected from different books. Okay, boiling points. Boiling points. Here, component A is water. This is composition. Composition. Boiling point of A, boiling point of B, and azeotropes. Boiling point of azeotropes. Okay. A component and B component. We have A component, B component. Okay, A component is water. We have A component as water. B component is ethyl alcohol. Composition mass percentage of B. Mass percentage of B. Understood that remaining one is A component. We have 95.6%. Component A boils at 373 Kelvin. Boiling point in Kelvin 373, and this is 351. Then boils at 351, 351 point, boils at 351.5 Kelvin. Boils at 351.5 Kelvin. Kelvin. And second one we have A component is water. Second example, N-propyl alcohol C3SMOH, and the composition is 72.0. That is N-propyl alcohol composition is 72.0. And component A, you know that water boils at 373 Kelvin, whereas this boils at 370.2. Then they are boiling at 361 Kelvin. Next one we have component A, benzene, and this is acetic acid, benzene acetic acid. Composition of acetic acid is just 2%, and the boiling point of benzene is 353.1 Kelvin, and another one is 390.9 Kelvin. They boils at 353.1 Kelvin. Okay. And we have another example, chloroform solvent. In that we have ethyl alcohol. Ethyl alcohol, the mass percentage is 6.8%. 6.8%. 6.8%. Then boiling point of chloroform is 333, 34.2, and this is 351.3, and the boils at 332.2 Kelvin. Okay. So what is the meaning of this? From the data, from the values, for you this boiling point, remembering example is not necessary. Just which are the percentage is necessary. They are asking competitive exam. The percentage, so and so percentage of this component is there means azeotropic mixture. The given question like this: which of the following forms azeotropic mixture? Which of the following forms azeotropic mixture? From the option they are expecting, they will give the percentage by mass of the components. They will give the percentage by mass of the component. From that you have to. Okay, so mixture of ethyl alcohol and water. If the ethyl alcohol percentage is 95.6, then it is minimum boiling azeotropic mixture. If N-propyl alcohol and water, N-propyl alcohol composition is 72.0%, then they are example for minimum boiling azeotropic mixture. See, what is that? N-propyl alcohol boiling point is A component, water boiling point is 373. Boiling point of A, water is 373. N propyl alcohol boiling point is 370.2. When this A and B are mixed, there is a formation of azeotropic mixture. They boils at 361 Kelvin. This is 373. This is 370. They boils at lower temperature 361. Therefore, they are called minimum boiling azeotropic mixture. They are called minimum boiling azeotropic mixture. Benzene and acetic acid. Benzene boiling point is 353.1. Acetic acid boiling point is 390.9. But they boils at 353.1 Kelvin. Chloroform boiling point is 334.2. Ethyl alcohol boiling point is 351. Ethyl alcohol boiling point is 351.0. But they boils at 332.3. This is 334. This is 355. 332 less than the components. Generally, minimum boiling azeotropic mixtures they boils at the lower temperature than that of components. Mixture boils at lower temperature than that of the components actually. But sometime see this example, you see that this example is 351.5, little more, and this example benzene and acetic acid 351.1. One of the component is having 353.1. Actually, they should boil lesser temperature. That is the correct definition. Minimum boiling azeotropic mixture means what? Components should be there. Whatever the components are there, after mixing, whatever the mixture is forming, their boiling point should be less than that of the components. Actual definition. That is valid for, that is okay for these examples. You see this 361, this is 373, 370, 373, this is 373, this is 370, boils at lesser temperature. Okay. And benzene and acetic acid, no. This chloroform 334, ethyl alcohol 351, boils at 332, lesser temperature only. 332 is less than 334 and 351. So these two are okay. Minimum boiling azeotropic mixture. Even if it is going some other factors, because of some other factors, if it is going also maximum it reaches then 353.1. 0.5 or 0.1, one more extra Kelvin maximum. Other than that, it is not possible. So, minimum boiling azeotropic mixtures, those mixtures which shows large positive deviation from Raoult's law, they are the minimum boiling azeotropic mixture. Try to understand. Positive deviation from Raoult's law means components are not liking each other, they produces more vapors. Means they go to the surface of the liquid more easily. When they are going to the surface of the liquid more easily, more vapors are collected on the surface of the liquid. More vapors are collected on the surface of the liquid, then sufficient vapors are available to become equal to the atmospheric pressure. So, boiling point is what? Boiling point definition is what? It is a temperature at which vapor pressure of the liquid is equal to the atmospheric pressure. Vapor pressure of the liquid is equal to the atmospheric pressure. That is the definition of boiling point. So, the one liquid which is boiling at lower temperature means what? At that particular temperature, sufficient vapors are available to become equal to the atmospheric pressure. See, ethyl alcohol is boiling at 351 Kelvin. What is the meaning of that? Ethyl alcohol at 351 producing sufficient vapor molecule such that those vapor pressure is equal to the atmospheric pressure. See, boiling point is what? Vapor pressure should be equal to the atmospheric pressure. At what temperature you are doing, I don't know. It should be equal to the atmospheric pressure. Keep on heating liquid such that its vapor pressure is equal to the atmospheric pressure. See, think in this way. Why ethyl alcohol is not boiling at 300 Kelvin only? Why it is at 351 Kelvin only? Because at 350 Kelvin, sufficient number of vapors are not coming on the surface of the liquid, so that its pressure is not equal to the atmospheric pressure. Sufficient number of ethyl alcohol vapors are not collected on the surface of the liquid, so that they can become equal to the atmospheric pressure. Same ethyl alcohol, if the temperature is 351.5 Kelvin, 351.5 Kelvin, so 351, their vapor pressure is equal to the atmospheric pressure. Same way you think, why water is boiling at 100 degrees centigrade only? Why water is not boiling at 50 degrees centigrade? Because at 50 degrees centigrade, sufficient number of vapors are not collected on the surface of the liquid, so that their vapor pressure is equal to the atmospheric pressure. Hence, water is not boiling at 50 degrees centigrade. At 100 degrees centigrade, what happens? At 100 degrees centigrade, the sufficient number of vapor, means which are present in the liquid, H2O molecules which are present in the liquid, once we are heating that, they get sufficient energy. Their kinetic energy increases. So, water molecules which are present in the liquid, they come to the surface of the liquid at 100 degrees centigrade. Sufficient number of vapors are formed. Then they are equal to the atmospheric pressure. So that is why water boils at 100 degrees centigrade. So what I mean to say that those liquids which produces more vapor pressure produces more vapors, their boiling point will be less. Ethyl alcohol boils at 351 Kelvin because at that temperature the vapor pressure of the ethyl alcohol is equal to the atmospheric pressure. Water boils at 373 Kelvin because at 373 Kelvin vapor pressure of the water is equal to the atmospheric pressure. Same thing, you can take any example. Acetic acid boiling point is 390.9. Acetic acid boiling point is 390.9 because at 390.9 Kelvin temperature, the vapor pressure of the acetic acid is equal to the atmospheric pressure. So, acetic acid boils at 390.9 Kelvin. Right? So, understand this much. Any liquid which is having more vapor pressure boils at lower temperatures. Right? I am talking for the solution which shows minimum boiling azeotropic mixture. Those solutions which shows positive deviation from the Raoult's law are the example for minimum boiling azeotropic mixture. These are the examples. They boils at minimum temperature. Practically speaking, little variation will be there, this much variation will be there, but theoretically if I am speaking, the solutions should boil at the lower temperature than that of components. Minimum boiling azeotropic mixture. Opposite to that, maximum boiling azeotropic mixture. Opposite to that, this is minimum boiling azeotropic mixture. Then we have maximum boiling azeotropic mixtures. Maximum boiling azeotropic mixtures. Maximum boiling azeotropic mixtures. Their examples are different. Here examples are different. Different examples are there for a minimum boiling azeotropic mixture and maximum boiling, obviously, because how this shows what type of deviation from Raoult's law that matters. This shows what type of deviation from Raoult's law that matters. These are only for need. Remember students, they are not asking question based on this table in theory. They are asking for need. What I am taking in today's class, beginning 10-15 minutes only it is for theory. Remaining all is for need only. Because azeotropic mixtures concept is important concept, but unfortunately they are not discussed much in theory, not given much in theory, so that I am explaining here. Okay, so I'll write examples for maximum boiling azeotropic mixtures now. H2O, HCl, mass percentage of HCl is 20.2%, boiling point is 373 Kelvin, and this is 188 Kelvin. Azeotropic is 381.6 Kelvin. Okay. Then example we have component A is water, component B is nitric acid, and this is 68.0%. Then 373 Kelvin, 359 Kelvin, 393.5 Kelvin. H2O again, it is H2O. B is formic acid, and this is 77.0%. 373, 374. They boils at 380 Kelvin. They boils at 380 Kelvin. Then we have chloroform solvent. Acetone we have chloroform and acetone. They are the examples for maximum boiling azeotropic mixtures. 334.2 Kelvin, 329.1, and 337.7. Okay, you see that examples is evens there. They are the examples for the maximum boiling azeotropic mixture. Maximum boiling azeotropic mixtures. Maximum boiling azeotropic mixtures, which shows negative deviation from Raoult's law. This shows negative deviation from Raoult's law. Negative deviation from Raoult's law. Here the H2 mass percentage, HCl mass percentage is given. Mass percentage of HCl is 20.2%. Remaining is water. The boiling point of water is 373. The boiling point of HCl is 188 Kelvin. But they boils at 381.6. Maximum boiling azeotropic mixture. Mixtures which are boiling at a temperature more than the components. This is 373, this is 188, but boils at 381.6. When you are mixing HCl and water, HCl is this, the C. HCl boiling point is 188, water boiling point is 373. When I am mixing, there is a formation of solution. When you are heating this mixture, they will come out. They will come out to the surface of the liquid and vaporizes boils at 381.6 because there is an attraction between the components, right? So another example is H2O and nitric acid. The nitric acid composition is 68%. Remaining one is water. The water boiling point is 373. Nitric acid boiling point is 359 Kelvin. Boils at 393.5 Kelvin. Higher than that. 393 is more than 373 and 359. Maximum boiling azeotropic mixture. Same way, water and acetic acid we have 373, 374, but boils at 380 Kelvin. Higher temperature. Again, chloroform and acetone example. Acetone composition is 20%. So boiling point of chloroform is 334.2. Boiling point of acetone is 329.1 Kelvin. But they boils at 337.7 Kelvin. 337.7 Kelvin. So these are the examples for maximum boiling azeotropic mixtures. Okay, they boils at the higher temperature than the components, right? So this much is there for the tomorrow's test. Till today, I have completed whatever the syllabus I have mentioned. Big starts with the solubility of solid in liquid, and azeotropic mixtures. Okay, what are important for NEET level for this concept is that okay, problems based on the Henry's law. How what are the factors? What are the factors affecting for the solubility of solid in liquid, solubility of gas in liquid? Okay, what are the definitions of saturated solution, unsaturated solution, crystallization? Then, what is the mechanism of the dissolution? What is the mechanism of the solubility that we have to see? Then, Henry's law, problems based on the Henry's law, and then ideal solution, non-ideal solutions. Regarding ideal solution, non-ideal solution, they are asking many times examples only. Which of the following forms ideal solution? Which of the following forms non-ideal solution? Then solution which shows positive deviation from Raoult's law. Solution which shows negative deviation from Raoult's law. Then this one, azeotropic mixtures. What are the composition of the so and so component in their mixture to form an azeotropic mixture? What is the percentage? You should know what is the percentage of that solute what we are adding into a solvent, right? So this till this is there in your test syllabus. All the best for tomorrow's exam.